In this video, we're going to be learning about contingency tables, which is a way in statistics to calculate different probabilities and also show data. So, a contingency table is a table showing the distributions of one variable in rows and the other in columns, and it's used to study the association between these two variables. So here maybe we have this contingency table where we have dogs. So here's all our data about dogs. And then here's all our data about cats. Then we also took data about all our male animals. So here's our male animals. And then we also took data about our female animals. So from this, you can say certain things like I have 52 males and 48 females. So there's slightly more males than females. I also have, of them, there's 51 dogs and 49 cats. And notice all of these numbers I circled up all add to the same number. So they both add up to 100 in this case. I can also be really specific and say I have 10 cats that are males. I have 9 dogs that are females. So there's a lot of different data I can get just from this one table. So let's try to use this table to answer some different questions. So notice here we have all of our brown eyes or all of our blue eyes. Then we also have right-handed people and left-handed people. The first thing we look to is our total. So our total number of people that we asked is 92. So the first question asks, what percentage of people are left-handed and have green eyes? So the really important thing, one of the important things is the of people. Whenever you see of something, this is going to be our total. So in this case, what we want is out of the total people, how many are left-handed and green? So out of the total, which is 92, how many are left-handed and green? Well, that's going to be where they meet up at 4. So we have 4 over 92. If we want the percent, first off, let's divide these two numbers into a decimal. So we get 0.0434. If I multiply by 2 or move the decimal place over 2 to the right, I get 4.34%. Let's try another one. So in this next example, it says what percent of right-handed people? So now our total is out of all right-handed people. And it asks how many have blue eyes. So blue eyes out of the right-handed people. Now this is where we have to be really careful. Here's our total. So our total for right-handed people is 66. Now look, our total is not 92. We're just talking about if I made all the right-handed people go into one group. Now how many of them have blue eyes? So now our total isn't the total. I'm looking for how many of them have blue eyes. Well, that is 19 of them. So 19 out of 66. Next up, what percent of blue people are right-handed? So now I'm looking for blue people that are right-handed. Blue-eyed people, right? So here's my blue-eyed people. The total number of blue-eyed people is 26. And if I look in that highlighted section, how many of them are right-handed? Well, there's 19 of them out of the 26, not 20. Next up, it asks how many percent of people have brown eyes. So here, I'm looking for of people. So here's the total. How many of them have brown eyes? Well, the total of brown eyes is 45, and the total number of people is 92. So I say 45 out of 92. Oh, and let's go back for these two. I forgot this. Let's make these all into decimals, and then it asks for percent. So this is 0.28 if you divide it, which if I move the decimal place 2 to the right is 28%. if you divide 19 over 26, you get 0.73, which is 73%. And if 45 divided by 92 is 0.489, which is 48.9%. Now last, it asks what percent of people are right-handed or have brown eyes. Now this is the part where we need to be really careful. Let's use red, I guess. Let's say here's my collection of all the people that are right-handed. I also have a collection of people that have brown eyes. Some of those people are right-handed. But just because I have brown eyes doesn't necessarily mean that I'm right-handed, right? So here's my brown-eyed people that overlap with the right-handed people. So the formula that we're going to use, notice if I add this up, I have my brown-eyed people. So I count them once, and I count my right-handed people once. Notice I end up counting these people twice. So what my formula is going to be when I have something like this or that is I'm going to add up the number of right-handed people plus the number of brown-eyed people, and I'm going to subtract off once the number of people that are right and brown-eyed, because I count them twice. I only really want to count them once. So what I'm going to do is the number of right-handed people, the total is 66. The number of brown-eyed people, the total is 45. And I'm going to subtract off that one group that's right and brown. So here's right and brown, they intersect, that's 32. So I'm going to subtract off 32. And divide it by the total number of people, so that's 92. I end up with 79 divided by 92, which will turn into 85.8%. So this Venn diagram is really, this is the total number, that's 66. This total number is 45. There's 32 in the middle. So down here in the middle is 32. If you do the math, if you take 66 minus 32, you get 34. And if you take 45 minus 32, you get 13. So that's our actual total number of people.